Hello my friends, good morning. This time I'm going to do this video in English, and I hope you will be not angry with me because I need to practice the language. I have not a contact that is some time, and that's good for me, you know, to make sometimes some videos in English. So I want to calculate the Laplace inverse transform the logarithm of 1 minus 1 over s squared. And what does this mean? This means that, let us say there is a function, let us call it by f of t, which the Laplace transform of f of t, it's equals to the logarithm of 1 plus 1 over s squared. And sometimes to solve some math problems, it is necessary to have a feeling, and sometimes it is not very easy to get that feeling. Let's put an eye over here at the Laplace transform of f of t, which is equals to the logarithm of 1 plus 1 over s squared. And let us try to calculate the Laplace transform of t times f of t. And for this case there is a property. As you know, the Laplace transform of t to n of f of t, it's equals to minus 1 to n, and the derivative of order n in order of s of f of s, where f of s is the Laplace transform of f of t. Here I'm looking well, and I made here a mistake. Let us say not f of t, but f capital F of s, okay? This is equals to the Laplace transform of f of t. So let's continue. So applying to this property, it is easy to understand. I will get minus 1 to 1 times the derivative of the first order, okay, of the Laplace transform of f of t. In this case, it is the logarithm of 1 plus 1 over s squared prime, okay? So it is the same as to have minus, and now I'm going to calculate the derivative of the logarithm of 1 plus 1 over s squared. As you know, it is the same as to have 1 plus 1 over s squared prime over 1 plus 1 over s squared. And now I'm going to make the calculations. It is the same as to have minus the derivative of 1, it is 0, and now I must derivate 1 over s squared, which is equals to s to the fourth s squared derivative of 1, it is 0 minus 2 times s. And now at this part of the expression I'm going to give the same denominator, and I'm going to turn it more simple. So it will come s squared plus 1, okay? And now it is more easy. I will get a more easier expression, because as you can see, minus times minus, it is plus, and I will get 2 times s to the third over s to the fourth times s squared plus 1, okay? Let's go to simplify the expression. It will come 2 over s squared plus 1. So in this moment I can say of course, I can say that the Laplace transform of t times f of t, it is equals to 2 s over s times s squared plus 1. Okay? And now I'm going to express this fraction in terms of a sum. As s is a polynomial of the first degree, I have no problems, but put an I here at s squared plus 1. There is no real zeros, so to make this the composition, I must do like this: 2 over s times s squared plus 1, it equals, let us say, an a over s plus b times s plus c over s squared plus 1. Okay? And now I must calculate the values of a, b, and c. So let's go to put here s squared plus 1 and here s. And let's go to make the calculations. At the denominator I will get s times s squared plus 1. Okay? And at the numerator I will have, let us see, a times s squared, it is a s to the s squared plus a plus b s squared plus c times s. And now let's organize the polynomial at the numerator. So at the numerator I will get s times s squared plus 1. At the numerator I will have a plus b times s squared plus c times s plus a. Okay? And so it is quite easy to understand that I will get a system of equations, and a times b, it must be equals 0. And as you can see, c, it must be also equals 0, and a, it will get the value 2. So in this way it is very easy to understand that p it equals to minus 2, c equals 0, and a equals 2. So now I can say that the Laplace transform, let's put another color, yellow maybe, Laplace transform of t times f of t, it's equals, I have here the expression, you see, so it is a question of substitution of a by 2 and b by minus 2 and c by 0, and I will get 2 over s plus, let us say minus, because the value of b it is minus 2, minus b times s over s squared plus 1. Okay? And now as you can see, I have the Laplace transform of t times f of t. Okay? And now let's go to apply to the inverse to the both sides of this equality. So I will get the Laplace transform inverse of the Laplace transform of t times f of t, and it will be the same as to have the Laplace transform inverse of 2 over s minus, I wrote here b, but it was not b, it must be 2, so I'm going to correct this and I'm going to put here, I'm sorry, 2 times s. Okay, so I'll get here 2 times s over s squared plus 1. As the Laplace transform inverse breaks what the Laplace transform does, it is quite simple to understand. I think that over here I will get t times f of t. which is, and now equals, and now applying to the, because the Laplace transform is a linear application, so I can put this number 2 outside of the symbol of the Laplace transform inverse, and I will get 2 Laplace transform inverse of 1 over s minus 2 times s squared plus 1. S squared plus 1. I'm going to close here the parentheses, and I'm going to put these 2 off because I have not the need of it at the numerator, because I put it here. So now as you can see, the inverse of 1 over s, it is 1, and this is the cosinus. As you can see, the Laplace transform of cosinus of t, it's equals s over s squared plus 1. Okay, so now it is quite simple to understand that t times f of t, it's equals to 1 minus cosinus of t. Okay, and so now I'm arriving to the end of my question that I put in this group, because now I'm going to solve this equation in order of f of t, and I will get, of course, f of t equals 2 times 1 minus cosinus of t over t. Okay, so now I did solve the problem, but I think that this problem was not very easy, because sometimes to solve some math problems it is necessary to have a feeling, and if I had not the feeling that to calculate, let us say like this, the Laplace transform of t times f of t, I think it was not so easy. But putting an I in this expression and making the calculation of the Laplace transform of t times f of t, the things will come very easy. I tried to make this video a little bit funny, because I am playing the role of a guy who is behind the screen, helping the students for a better Portugal. Bye bye, see you soon.